Good morning, students. Today we are going to see certain topics in course outcome 4. Okay, so actually we have already seen some topics actually in the case of open channel flow. The remaining topic is actually notches and weirs. That will be seeing what is notch, what is weir, what is the difference. Okay, shall we start now? So we are going to see the notches, what is the types of notches available, weirs, what is meant by weir types, and difference between notch and weir. So what it is notch is actually it's a device used for measuring the rate of flow of a fluid through a small channel. Okay, so you consider a small tank you can consider. So how fluid is flowing. So it may be defined as an opening in the side of tank or small channel such that the liquid surface in the tank or a channel is below the top edge of the opening. Okay, so you can see this bottom edge of the notch over the liquid flow is, we call it as the sill or we call it as the crest. Okay, you can see what is weir. Weir is actually, it's a larger structure. When we compare with nozzle, it's a concrete or masonry structure. It is placed in the open channel over which the fluid is being flowing. So what actually this weir will be causing an increase in the water depth. As the water is flowing over the weir, what happens? There will be increase in the water depth. Okay, so if there is, you can see, if the flow rate is greater, what happens actually? It will be directly proportional. So the water increase in depth, water depth of flow also will be increased if there is a greater flow rate. So the top of the weir over which the water flows is called as crest. That we see what it is. Sorry, ma'am. So you can see that the top of the weir is called as crest, whereas the bottom of the notch, which the liquid flows, we call it as sill or crest. Okay, you can see the difference. So where is this weir used? Already I told you, notch is used for measuring in the case of tanks or very small channels. But in the case of weir, actually, it's used for measuring larger discharges of rivers or big canals. So generally, in the form of a vertical wall, it will have vertical wall, the sharp edge of the top. Okay, so this will be opening along, this will be run along the open channel. So this is very important. Okay, many get confused with notches and weirs. They just consider both are the same. Actually, notch is opening which is provided in one side of a tank or reservoir. Okay, what happens actually? This liquid level will be below the top edge of the opening. Just imagine, but here actually it is constructed of a river or the canal. That will be the difference. This is tank or reservoir, but here it's river or canal which is of larger structure. Okay, and this water will be what is the purpose of weir actually? To store water on the upstream side. Okay, this bottom edge of the notch will be actually you can see along the bottom edge of the notch only the water will be flowing, and that will be called as a sill or crest, whereas the top of the weir which the water flows, we call it as the crest. Okay, so this weir will be made of cement, concrete and masonry. So a notch will be usually made of metallic plate. Okay, so notch is actually used for measuring small discharge of small stream or canal. So this weir will be used for measuring the large discharge of rivers and large canals. So notch will be of small size and weirs will be of bigger size. Okay, so the condition of flow in case of weir are practically the same as that of rectangular notch. So that sometimes actually this are used as vice versa. So practically somewhat the conditions of flow will be actually this will be large, this will be slow, but we are using it vice versa. Okay. So how was notches are being classified? So notches are being classified rectangular, triangular based on the shape. Trapezoidal, it can be stripped. So according to the effect of the sides of nappy, it's notch with the end contraction. Sometimes notch can be without the end contraction, or it could suppress the notch. Okay, and how we are classifying the weirs? So we are being classified based on the shape of the opening, the shape of the crest, everything else. Okay, so rectangular, as we are having in the case of a notch, we have rectangular, triangular, trapezoidal. So according to the shape of the crest, we can have sharp. It will be sharp one. It can be a broad and narrow, and OG-shaped weir also we do have it. Normally, you go for sharp, broad and narrow. We are learning it. And according to the sides on the emerging nappy, it can be weir with end contractions and also the weir without end contraction. So normally, this topic will be learning more about the types of based on the shapes only. Okay, you can see that the discharge over here, rectangular and short weir. So the expression over there, rectangular notch of weir, is used to control water upstream and downstream. Okay, so this will have high discharge values. The first one is the supposed to rectangular weir. For example, here the weir will be extending across the entire channel. So how it will be? This weir's length will be equal to the width of the channel. Okay, so that will be fully what? Okay, in the case of contracted weir, this is cut into, adding to the head loss, you will have a contracted rectangular weir, etc. So it will be extending only to, for the particular part of the channel, etc. Okay, and the length of the weir will be different as the width of the channel. Okay, you can see the difference here. Alright. Okay, so what is the empirical formula for here? So we can have it as your Q is equal to, you can see this formulas. Okay, so this is the formula in order to find the discharge over this. This is HM will be the head over the weir, P will be the height of the weir plate, and when you take it as everything else, acceleration due to gravity, everything else will be measuring, and you will be finding out the discharge over the weirs. This is for rectangular weir, and we have it as your this is the formulas. Okay, so the practical limitations, this is actually Hepworth's law formula. This you can see that certain values, depending upon the value of your length or height or head of the weirs, you will get the value of your discharge. And this is actually discharge over the triangular notch or your weir. Okay, so you can see here the shape. From that shape you can go it for it. This is actually V-shaped weirs. Okay, the V-shaped V-notch is normally a 90-degree opening. It can be also 45 degrees, etc. So you have it as Q is equal to 8 by 15 into your 2 root of 2g c theta tan theta by 2 h power 3 by 2. So Q will be a discharge, and C is a discharge coefficient. Theta will be in degrees, in which is a notch angle. Okay, next one will be a discharge over a stripped notch. Okay, a stripped notch will be a combinations of your rectangular notches. Okay, so that's how it will be. Actually, you can see that this is a rectangle and another one is a bigger rectangle. So it will be an addition. Okay, you can add it and you will get your total discharge. So when you take it as a discharge over a sharp crested weir, a weir with a sharp upstream corner or edge such that the water springs under this one. So you can see that the sharp crested weirs will be, you have a thin rust or resistant metal plate. It will have it as a metal at the top. You will have a metal at the top, okay, and it will be perpendicular to the flow of water. It will be placed at a perpendicular direction. So normally this syllabus we do more concerned about some formulas and problems regarding the types of weirs. That is, we have it in a single topic. If you are learning it as a hydraulics, you will have nearly for 5 units. Okay. So the sharp crested weirs are normally used for the smaller weirs and also canals. Okay, so you have the formula for finding out the Q. Okay, the main forces governing the flow of air is actually gravity and inertia. So this gravity will be, how it will be? It will be accelerating the fluid from its free surface elevation upstream of the weir to a larger velocity as it flows down from the hill. It is formed by the napping. Okay, all the viscous and surface tensions also will be having, but we are neglecting this very small, so we are nearly neglecting it, right? And again we have and again generally approximately we have some coefficients formulas also for finding these effects. And next one is a discharge over the broad. You can see the broad crested weir. We are having a wide crest. Okay, if the crest is very wide, we call it as a broad one. H is actually the height of the water above the crest, and L is the length. Okay, if 2L is greater than H, 2 times of L is greater than H, it is broad crested. If 2L is smaller than H, we call it as a narrow crested. So actually they are very robust. Okay, so they will be made of reinforced concrete, which usually span the full width of the channel. They'll be, and they exist for flow measurement, and this will be normally used in medium-sized rivers and canals, where only you can use here. Okay, so the broad crested weir has the advantage of operating effectively with higher downstream water levels than a sharper crested weir. And that's the advantage over the sharp crested weir. So another one is cost-effective installation. The design of construction will be very, designing is very easy. Okay, small head loss only. You can measure the discharge in small to medium channels, etc. Camera of passing floating debris. Theoretical calibration also you can do it. What disadvantages? Some disadvantages what we have is actually when you are placing this weirs to the full passage, isn't it? So the fish passage may be disrupted. So you may there will be a disruption in the ecological equilibrium. Okay, the sediments also can be deposited when it is flowing from one place to another. And the channel is actually what happens is the sediments can also prone damage to the accuracy of the rating curve. Okay, head loss will be occurring along the weir, which will lower the energy of the flow. Thanks for your patient listening.